Good morning. Welcome to all. This is Tanu Gupta from IT department and from Ajay Kumar Garg Engineering College. Today, my topic is on clustering in data mining. Okay, it is also a very important topics in data analytics. So we cover in this lecture clustering in data mining. Okay, so first we understand what is clustering. Clustering basically is a group of objects that belong to a same class. In other words, similar objects are grouped in one cluster and the dissimilar objects are grouped in another cluster. Clear? So what is a cluster? Cluster is a group of objects that we combine a similar entities in one cluster and a dissimilar quantities in another cluster. Okay. Then the process of, and then what is a clustering? Clustering is a process of making a group of abstract object into the classes of similar object. Okay, so here we have many definition of clustering. First, what is cluster? Cluster analysis or clustering is a task of grouping a set of objects in such a way that the object in the same group are more similar to each other than in the other groups. Okay, so cluster is a group of objects that belong to a same class. In other words, similar objects are grouped in one cluster and the dissimilar objects are grouped in another cluster. Okay, so clustering is a process of making a group of abstract object onto the class of similar object. Okay, so this is a basic concept of cluster and clustering. So we have clustering falling under the category of unsupervised machine learning. So clustering basically आपकी unsupervised learning machine technique है in which a supervision is not provided. Okay, in supervision is provided, a teacher is provided, or we have the inputs and output. But clustering, in the case of clustering, there is a unsupervised machine learning technique, and it is one of the problem that machine learning algorithm basically have. Clustering only utilizes input data to determine the pattern. Clustering anomalies or similarity in its input data. Okay, so these are the properties of clustering. A good clustering algorithm aim to obtain cluster whose the inter-cluster similarities are high. For example, we have a two-dimensional space. Okay, these are the individual clusters. Okay, on the basis of similarities, we combine these cluster into one and these cluster into another cluster. Okay, so what is that? Intra-cluster similarities are high. So within the cluster, the similarities of this cluster and this cluster is high as comparison to the other cluster. So this is called intercluster and this is called the intra-cluster similarities. So what is intercluster similarities are high? It implies that the data present inside the cluster is similar to one another. Okay. For example, if we have a many data points or many clusters in a single object, so the similarities and characteristics of this object and this object is similar but dissimilar to the object that is present in the another cluster. Yeah. Then next property of the cluster, which is also important, intercluster similarities and is low. Okay, if we have a data objects, okay, intercluster similarities is low. It means each cluster hold data that is not similar to other data. The properties of this cluster and the properties of this cluster is different but similar to the properties of this cluster. Okay, so in a simple way we understand, if we have two clusters and there are 5 objects in one cluster and the 5 objects in another cluster, so the similarities and the characteristics of 5 objects in one cluster is similar within the cluster and are dissimilar to the object that are in the another cluster. Okay, so intercluster similarities are high and the intercluster similarities is low. Basic, these are the two properties of clusters. Okay, so these are the basic definition of cluster. As we explain, a cluster is a subset of similar objects. There is a subset of similar object, a subset of objects such that the distance between any of the two objects in the cluster is less than the distance between any object in the another cluster. So, like in this, if we have the data points, this is one cluster, consider this is another cluster and this is another cluster. There are three clusters in this. Then the properties or a distance between in this clusters is minimum as comparison to the distance of clusters between these two clusters. Okay, so this is understood by the second definition of the cluster, a subset of objects such that the distance between any two objects in a cluster is less than the object that are in the another cluster located outside the cluster. Okay, the connected region of a multidimensional space with a comparatively high density of objects. Then what is clustering data mining? As we discussed, clustering is a method of converting a group of abstract objects into classes of similar objects. Clustering is a method of partitioning a set of data or object into a set of significant subclasses called cluster. It helps the user to understand the structure or natural grouping in a data set and used either as a standalone instrument or to get a better insight into and distribution as a pre-processing step for other algorithm. Okay, so what is the requirement of clustering in data mining as a concept of data analysis? So what is the requirement? Why we require clustering if we have another regression technique? Why we require clustering? So the first requirement of clustering is scalability. We need highly scalable clustering algorithm to deal with large data set. In clustering, we have highly scalable algorithm like k-means algorithm, as we which are discussed in future lectures. K-means algorithm, a priori algorithm, these are very scalable algorithm, and these are the simple algorithm which organize the clusters of similar object in one and dissimilar object in another one. And the second requirement, which is also very important of requirement clustering, is ability to deal with different kind of attribute. Okay, so clustering is capable of handle different kind of attribute, which can be an interval based, or we can say a categorical, or we can say a binary data or a numerical data. Binary data which is of 0 and 1 form. Okay, so the third requirement is discovery of cluster with attribute shape. Discovery of clusters with attribute shape. So the clustering algorithm should be capable of detecting cluster of arbitrary shape. The clustering algorithm should be capable of detecting cluster of arbitrary shape, not a particular shape which is a circle or a spherical, arbitrary shape. It could be an any shape. They should not be bounded to only distance measure that tend to find a spherical cluster of small sizes. Okay. Then the next requirement of clustering is high dimensionality. The clustering algorithm should not only be able to handle low dimension data, but also the high dimensional data space. In the clustering, we have many algorithms who are dealing with high dimensional data as comparison to other algorithms which are use a low dimension data. Ability to deal with noisy data. Noisy data, we can say a redundant data or replicated data. So then database can contain noisy, missing or erroneous data, but we have a mini algorithm in clustering which is very good to calculate with the clustering or a erroneous data in such a way that may lead to a poor qualities. Okay, So the last requirement, which is also main, interpretability. Interpretability, the clustering result should be interpretable. Interpretable, comprehensible and usable. Okay. Now there are many clustering method. Clustering method can be classified into the following category. The first one is partitioning method, the second one is hierarchical, third one density based, grid based, model based and constraint based. These are the method which are dealing with clustering and in which they have many algorithm to deal with the clusters and to find out the similarities and dissimilarities of the objects. So one by one we discuss all of these method. Then the first method is partitioning method. As we understand as the name partition, we partition the data. We partition the data object into a cluster, predefined clusters. Okay, suppose we have given a database of n objects. Okay, we have a database of n object. There are n object in a database and partition method construct k partition. And in the partitioning method algorithm, we partition our data into k partition of data. We have given a data set and we have given a number of cluster in which we have to divide or we can say a partition the data points into a cluster. Okay, each partition will represent a cluster and k is less than n, where n is a number of object and k is already defined cluster. We have for example, let us consider an example. For example, we have 10 data points, okay, and we have to divide in 2 clusters based on the similarities or a distance or we can say another thing which was implemented in the algorithm. So in the 10 data points, maybe 2 data points are belong to a cluster A or 2 and the remaining A data points belong to a cluster B. So in the partitioning method, we have decided, we have given data points and predefined cluster in which we have to define we have to divide the data points into a predefined clusters. Okay, and which is also satisfies the following requirement. The first requirement is each group contain at least one object. Okay, so each group contain at least one object. If we have 2 clusters and every cluster contain at least one object. There is no 0 object, maybe 2, maybe 3, but at least one object is present in that cluster. Each object belong to exactly one group. If we have 10 data points and we are divide into these into 2 or 3 cluster, then every object belong to exactly one group. There are no data points which are belong to 2 or 3 cluster. Okay, so each object must belong to exactly one group. There are something points to remember. For a given number of partition, for example k, the partition method will create a initial partitioning. Then it uses the iterative relocation technique to improve the partitioning by moving object from one group to another. Okay, so next method we have hierarchical method. This is also a method of clustering, hierarchical method. This method create a hierarchical decomposition of a given set of data object. We can classify hierarchical method on the basis of how the hierarchical decomposition is formed. There are 2 approaches here. In the hierarchical method, we have 2 approaches. The first one is agglomerative approach and the second one is divisive approach. Agglomerative approach follow a bottom-up approach and the divisive approach is follow a top-down approach. Okay, in agglomerative approach, what we have do in the agglomerative approach? We consider every data points as a separate cluster and then merge them on the basis of distance, on the basis of similarities and characteristics which are similar to one another, and merge them when only one cluster is formed. Now, so this is a concept of agglomerative. and divisive approach. The divisive approach is a top-down approach. In this, we start with all the object in the same cluster. This is opposite of the agglomerative, in which we consider all the data points, all the object are in the same cluster, and we divide it, and we divide, or we can say a split into different clusters. Okay, and we continue the splitting when every other object is divided into a single cluster. So this is a basic difference between agglomerative and divisive approach of hierarchical clustering. In agglomerative approach, we follow a top-down approach, bottom-up approach, and in divisive approach, we follow a top-down approach. Okay. In agglomerative approach, we consider initially we consider every data points as a separate cluster and merge them when a final one cluster is formed. But in divisive approach, we consider all the cluster in single cluster and split, and then split into when this process is continue when all the object are belong to a individual cluster. So let's see a diagram, or we can say a graphical representation of agglomerative clustering. Let's see the graphical representation of this algorithm using a dendrogram. Note, this is just a demonstration of how the actual algorithm work. This is just a demonstration. Okay, this is not a working of the algorithm, how the calculation is performed. This is just a demonstration. All the proximity among the cluster is assumed. So we have 6 data points. Okay, A, B, C, D, E, F. In the agglomerative approach, we have 6 data points A, B, C, D, E, F. Initially, we consider these data points as a separate cluster. Now we merge, and in the second step, now we merge these cluster on the basis of similarities, or a distance measure algorithm, which we have discussed, discussed in future lecture also. We combine these two cluster B and C into a one cluster BC. Then we combine a D and E cluster, which is also have individual cluster, into a DE cluster. Then we combine DEF cluster, and this process is continue when all the objects are belong to a single cluster. Okay, so first we have A, B, C, D, E, F. These are in step 1 individual cluster, and in the second step we merge BC and DE, which are belong to a same cluster. BC belong to one cluster and DE belong to another cluster. Then DE and F, which are 2 different cluster, are combined into one cluster, that is DEF. Then DEF, BC, which are in another clusters, are combined, which becomes a BCDEF cluster, and the last one ABCDF. So this approach is a bottom up approach. Okay, follow a bottom up approach. So this is the explanation of this agglomerative approach. Consider each, as we discussed, consider each alphabet as a single cluster and calculate the distance from one cluster to from all other cluster. And in the second step, comparable cluster are merged together to form a single cluster. Let's say clustering B and C are very similar to each other. Therefore, we merge them in the second step. Similarly to cluster D and E, at the last, we get the cluster A, B, C, D, E and F. Okay, and in the step 3, as we discussed, we recalculate the proximity according to the algorithm, then merge to the 2 nearest cluster DE together to form a new cluster. Repeating the same process, the cluster DEF and BCE are comparable and merged together to form a new cluster. We are now left with the cluster A, B, C, D, E, F at the last. Okay, so step 5, at last the 2 remaining clusters are grouped together to form a single cluster, that is A, B, C, D, E, F. So this is a basic approach of agglomerative algorithm, in which initially we are taking all the data points are a separate cluster and merge them together until we have find a single cluster. All the objects are belong to the same cluster. Next is divisive algorithm. Divisive approach, or we can say a divisive approach of hierarchical clustering in data mining. So what is divisive algorithm? Divisive hierarchical clustering is precisely the opposite of agglomerative. Divisive algorithm is the opposite of agglomerative clustering, which follow a bottom-up approach. Divisive algorithm follow a top-down approach, in which if we have initially we consider all the data objects belong to a same cluster. Then we divide the objects into two different, or we split the objects into two other different cluster, B, C, D, B, C, D, E, F. B, C, D, E, F. B, C, D, E, F. Again we further divide B, C, D, E, F into B, C, D, E, F into D, E, F. I think and BC. Then further we divide the DEF into DEF and BC. We follow this step when we not finding all the objects are belong to a different cluster. Okay, so in the divisive clustering, we take into account all of the data point as a single cluster, and in every iteration we separate the data points from the cluster which are not comparable. In the end we are left with n cluster. Okay, so this is a basic concept of agglomerative approach and divisive approach. In agglomerative approach, we consider all the data points are individual cluster, but in the divisive approach, at the end we are left with n cluster. Okay, this is the basic difference of agglomerative and divisive algorithm. Then the next is density based method of clustering in data mining. So what is in method? This method is based on the notion of density. Okay, it assumes as there is a dense area, notion of dense area. Okay, the basic idea is to continue growing the given cluster as long as the density and the neighborhood exceed some threshold. We assign our data points into a single cluster, then becomes a dense, and when follow these total step when it becomes to exceed some threshold. So this is a basic concept of density based method, that is for each data point within a given cluster, the radius of a given cluster contain at least minimum number of points. The density based clustering method connect the highly dense area into cluster, and the arbitrary shaped distribution are formed as long as the dense region can be connected. The algorithm does it by identifying different cluster in the data set and connect the area of high densities into clusters. The dense area in the data space are divided each other by sparsing areas. So this graphs show a simple dense area in which there are many data points in this cluster and there are many data points in another cluster. This is basically showing a density, a dense area which follows some threshold. This algorithm can face difficulty in clustering the data points if the data set had varying density. If there are many clusters of varying density, so there is a problem to analyze these areas and to find out a typical outcome, finding of outcome of this algorithm. So this is, we can say this is a disadvantage of this algorithm because of high density and varying density and high dimension. Then next method is grid-based method. Okay, so as we understand the grid base, as we understand the naming grid, what we have in our mind, a form of grid like that. A form of grid like that. We divide the data points into a grid like that. In the grid-based method, a grid is formed using the object together. That is, the object space is quantized into a finite number of cells that form a grid structure. One of the major advantages of the grid-based method is fast processing time, and it's dependent only on the number of cells. In each dimension, the quantity is the space. The processing time for this method is fast much, so it can save a time. This is an advantage, or we can say advantage of grid-based method. The processing time is high. Processing time is high, so this algorithm saves time as comparison to the another algorithm for computing steps. Then next is model based. Next is a model based method of clustering. Okay, in this model based, all the clusters are hypothesized in the order to find the data which is best suited for the model. Therefore, it yields the robust clustering in all. Then the last one is constraint based method. The constraint based clustering method is performed by incorporation of application or user oriented constraint. A constraint refers to the user expectation or the properties of desired clustering method. And the constraint provide the interactive way of communication with the clustering process. The user or the application requirement can specify the constraint. So these are basically the main methods of clustering algorithm in data mining.